Okay, Cappuccino, I was asked to go over some problems from the Chapter 1 review section. So starting with problem number 3, they give you a formula for solving an equation in the form x cubed plus px equals q. And then they give you a problem, x cubed plus 3x equals 5. And they ask you to solve it using the formula and also using technology. So I did that. So first, what I did is I did it using the formula. So you can kind of see I did it in a different pen color. Sorry, I'm not doing this live, but I did it once before and then I messed up. So I don't feel like copying it over again. All right. So when we look at this, our P is the coefficient of X and our Q is the constant. So I'm just going to plug those in, my P's right here and here, and my Q's right here and here. And here and here. So notice this is exactly the same as this. The only difference is this is plus q over 2 and this is minus q over 2. So I plugged in my p and my q here first. So I got 3 over 3 cubed plus 5 over 2 squared plus 5 halves. And then same thing over here. The only difference is that this is minus 5 halves. Now I noticed these nicely simplified a little bit. So before I started putting it into my calculator, I went ahead and did some simplifying. So 3 over 3 is 1. 1 cubed is still just 1. 5 halves squared, well, that's 5 halves times 5 halves, which is 25 fourths. And then I kept that. And then this is exactly the same as this first term, except it has a minus 5 halves in the parentheses. Then I put this whole thing into my calculator, which oh, there it goes. Shoot. See, this is what keeps happening. So let me turn that off, let it adjust, and then turn it back on again. Sorry, the lighting thing is kind of an issue for me. All right, so there it is. You can't see, where is it? Let me go back up. There it is, right there. So I plugged it all in exactly the way that I have it here, except that instead of using the cubed root, I changed it to parentheses, and I used the exponent of 1/3. Rather than trying to do these, square root inside of a cubed root. I just changed the cubed root to exponent form. Okay, and then I have this in there as well. All right, so then I did that and I got the answer right there. 1.154171495. Okay, the next part of the problem says use technology. So I used technology. I entered into my y equals. I put in x cubed plus 3x for the first equation and y equals 5 for the second equation and looked for the intersection. So if I graph that, you can see there right there. To find the intersection, I did second trace and I went down to intersect, which is 5. And it asked me, what's the first curve? And I said the blue one. And then the second curve is the red one. Hit enter. And guess, hit enter again. And then it told me that it believes the answer is x equals 1.1541715. Whoa, pretty much the same thing as this, except instead of 495, it just ends with a 5 there instead. Okay, so then it says, well, what's the percentage error? I could not get the answer that they gave in the back of the book, and it didn't matter which way I did it, whether which one I divided by, but percentage error, which we went over in class on the warm-up today, is you subtract your two values that you got and you divide by the what you consider to be the more accurate value, which the way that they worded the problem, I assumed meant the one from technology. But I did this equation, I did it the other way where I divided by this value and it still gave me the same answer. So here's the answer that I got when I divided these. So I subtracted these two values and then I divided by this value. And then I did it again and I still got pretty much the same answer. So here it is where I divided by the technology answer. Oh, and there we go again. You can't see it. I have to readjust the lighting. Yes, this is going to happen all semester. I got to figure this out. All right, so here we go. So I took the difference. Let's go back to that. So I subtracted the two values, one from the formula and one from my graphing calculator. And I got -5 times 10 to the -9th. I don't have to worry about the negative because I'm going to take the absolute value of it. And then I divided by the value from my graphing calculator, and I got this, 4.33211182 times 10 to the -9. To change that, that's a decimal. To change it to a percent, I would multiply it by 100, which basically would just change my exponent here. The exponent on the base 10 times 10 to the -9. It would just change it to the -7. And then I tried it again, dividing by the number that I got from the formula, and notice I basically get the same answer, which is not what matches the back of the book. So I don't know what's going on with the back of the book. Okay, this is what I got. So no worries there. To change this to a percent, I'm going to do that 4.33. Oops. I'm going to go 4.33. You can't see me typing it in, but I'm doing it, times 10 to the -9. I'm going to times that by 100, and we should see our exponent change. So there it is. If you can see it without me having to turn the light on and off again. 4.33 times 10 to the -7. Percent. 4.33 times 10 to the -7%, which is not what they get in the back of the book. So I have no idea why that went wrong. If anybody can figure out, let me know. But the idea here is that you should be able to use formulas or technology. And in this course, really, we're interested in using technology. This crazy formula here, it's like nobody uses that. We just graph it and find where they intersect. Okay, that was problem 3. And how do I stop recording on this thing? There it is. Bye.